Listen, in this question here, we are asked to find dy dx given that y is equal to x to the power tan x plus sine x to the power cos x. Here's the thing. This is an example of a complex differentiation problem. To solve something of this magnitude, now look at this. Look at this. Let me show you something. If y is equal to, let me use this to illustrate something. Y equal to x to the power, let's say 4 plus 3x to the power 7, for instance. Let's say this. Look up, please. From here, what's the value of dy dx? 4x cubed plus, this is 4x cubed plus 21x to the power 6. Now, let me do something. I'll pick up the questions, break them into several questions, and combine the answer. What do I mean? I'll pick up this question. I'll say y equal to x to the power 4. What's the y dx here? 4x power what there? 3. Pick up the second one there. Y equal to 3x to the power 7. What's the y dx here? 21x power what there? 6. Combine this. It becomes this plus this. Is it correct? Yes. This is the approach you give to this question. Because this whole thing here on its own is a problem. This one here on its own, you don't want to carry both problems at once, trust me. So you want to pick them up, deal with them separately. When you're done, combine their individual answers. You have the same thing. That's the approach for this question. So please look at this. In solving this question here, I asked what we should do first. Somebody said take log of both sides. That's correct. The only thing now is that if I take it, you don't take log of each term. No, you take log of both sides, not each term. Well, you can do of each term anyways, but that's advanced maths. For this, look up please. I'll pick up this one here. I'll say pick up x to the power tan x and differentiate. And differentiate. So I'll just take y equal to x to the power tan x. All right. At this point, it looks easier. Get my answer combined with the second one. I want to solve this. What do I do? Take log of both sides. Well, log, okay. But I usually prefer ln. Whether log or ln. When it comes to differentiation, log and ln are almost the same thing. If I differentiate log x, what do I get? What about x? If I differentiate ln x, what do I get? What about x? So take log of both sides though, take ln of both sides though, it's the same thing. But please, for professionalism, always take ln. I think most authors prefer to use ln than log, but they're the same thing anyways. Take ln of both sides, take ln, this, not in ln, of both sides. Look up please. Ln of y is equal to ln of what there? X to the power what there? Than x. At this point, if I take ln of a term, what happens to the power? Comes down, right? If I take ln of any term, the power comes down here. So I'll have this as what there? This gives you ln y is equal to, power comes down here, I'm having tan of x, ln of x. So I have this. All right, I'll get this. At this juncture, it becomes easier to solve. How does it become easier to solve? This becomes implicit. Hold on. To solve this one here, observe that I have to solve y. I have to differentiate y and x simultaneously. To differentiate y here becomes what there? Implicit differentiation. Differentiate x here. Which method do you use here? Product rule. Let's use product rule. Product rule, this is what there? U. This is what there? It is product rule because they are doing what there? Multiplying. Product rule says v du dx plus u dv dx. So let's get du dx and the v dx. If u is equal to tan x. To get the u dx, all I need to do is differentiate tan x. Please, if I differentiate tan x, what do you get there? Sec squared x. You have this. Please, v is given by ln x. The v dx means differentiate v. If I differentiate ln x, what do you get there? All right. So for this, I will use product rule. For this, implicit. Now, how does implicit work? That's the question. To differentiate using implicit, it means do your normal y differentiation. Yeah? But whenever you differentiate y, add what's there? dy dx. That's implicit. Okay. Now listen. Let's assume this was what ln x. If I differentiate ln x, what do I get there? 1 over x. Please. If you differentiate ln x, you get 1 over x. Now, if I now differentiate ln y, what do I get there? So it becomes 1 all over y. Attach what there? dy dx. You only attach dy dx whenever you're differentiating a y term. Is equal to differentiate this term here, you must use product rule because this is multiplying this. What's the product rule there? V du dx plus u dv dx. Please help me out, please. What's v? What's v? V is ln x. What is du dx? Sec squared x plus what u? Plus tan x u. What is the v dx? The v dx here, that is 1 over x. So I have this. V du dx plus u dv dx. Okay, from here, let me just simplify here. This is equal to, usually, listen, usually when you have a ln term multiplying this, in the usual arrangement, it is preferable you take the term before the ln. All right, what I'm saying is that this becomes sec squared x ln x. That's what I'm saying, right? Sec squared, this is ln x times sec squared x. What you have is sec squared x ln x. These are the same thing. If you want to leave it this form, no problem. But this has to simplify. Plus, for trig function also, it is preferable you move this man here. So it becomes what there? 1 over x tan x. So you have this, basically. From here, I have, from here, I have 1 over y. Sorry, let me conserve space, please. From here, I have 1 over y dy dx. This is equal to what there? Sec squared x ln x plus 1 over x tan x. Please, how do you simplify this? What do you do? If I have this, how do you simplify this? What do you do? Oh, did you say divide both sides? Multiply both sides. By what? By y now. I have 1 over y here. I want to move y over here. What do you say? You can say multiply by y or simply move y over here. That's the simplest concept there. Move this y over here. You have this one standing alone. So far as the y here is a denominator, move the y over here, it's correct. Or if you want to find, multiply both sides by y, is the same thing. So you move the y over here, I will have that dy dx is equal to, mind you, the y coming over here is multiplying everything here. So it becomes y into bracket. So if you now come and say y times this, that becomes y sec squared x ln x, then plus 1 over x tan x. I just moved y over here, but what's wrong here? What's wrong? Please, the y is supposed to multiply everything. So what do you do here? Put this in bracket. So y times everything here in bracket. What next? But what's the value of y? What's the value of y? If you're using y, remember that you're working with this. Don't go and take this one here. We're working with this. But y is equal to what there? X tan x. All right. So bring this here. We have that dy dx is equal to y x tan x, that's y, into sec squared x ln x plus 1 over x tan x. With this now, I have solved the first part. Done. Let's solve the second part and combine the answers. That's it. With this, I've solved the first part. Let's solve the second part and combine the answers, please. So listen up, listen up, listen up, listen up, listen up. Let's pick up second term there. So pick up sine x to power cos x and differentiate. Let y be equal to sine x raised to power cos x. Again, following the same pattern, my first task is to take ln of both sides. So take ln of both sides. What do I get there? Ln y equal to ln sine of x to power cos of x. So I have this. Work on this. If I differentiate ln y, okay, this one comes down first. So I have ln of y, it's equal to, so the power comes down, that's cos x into ln of sine x. Okay, this will be product rule. This is u, this is v, and that's equal to, please look at this, please. Please observe this. U is equal to cos x. What is the u dx? Differentiate cos x. What do you get? Minus sine x. Negative sine x. All right. V is equal to ln of sine x. Differentiate this. What do you have? What do you get? No. What do you get? Differentiate ln sine x. What do you get? What do you get? Now listen. The thing about calculus is that it's not a, how do I put it? Look at this. See something. If y is equal to ln sine x, please watch this. Let me pick this one here as a separate question. Please look at this. If you're given y equal to ln sine x and you're asked to find dy dx, which method do you use? What do you use? Chain rule. In using chain rule, you say let u be equal to term in the bracket sine x. What is du dx? Differentiate sine x. What do you get there? Cos x. Now y on its own is equal to ln, what's this man here? This is u. What is dy du? 1 over u. So we can say that dy dx is equal to what there? Chain rule, dy du times what there? Du dx. What's dy du, please? 1 over u. What's du dx? Cos x. Multiply this. 1 times cos x all over u. What's u? sine x. So what's the answer there? Cosx over sine x. Now let me show you something. Look up. Look up. Look up. See, we said if y is equal to ln x, we said what's the value of the y dx? What's the value? 1 over x. Why is it 1 over x? Here is the comprehensive idea behind it. If I'm differentiating a ln term, all you have to do is differentiate that term and take it as a numerator all over, repeat that term as a denominator. I have this. Differentiate x. What do you get there? 1 numerator. All over, repeat this. What do you have here? X. 1 over x. So in this case here, differentiate sine x. What do you get there? Cos x. All over, repeat it. This would have saved you all those stress. Oh, you got to start right. I start shouting. I got it. What do you write there? 1 over sine x. And you got it. What I did there. Alright, so what do I have there? Differentiate ln y. You get what there? 1 all over y. Attached what's there? dy dx is equal to, for here, use product rule. Product rule is v du dx. What's v? V is ln sine x. This is v into du dx. What's du dx there? Minus sine x. V du dx. If you want me to write out the formula, no problem. V du dx plus u dv dx. This plus what u? U is cos x. U is cos x. That's u. Into the v dx. What's the v dx? That becomes cos x over sine x. All right. V du dx plus u dv dx. All right. So this gives you, okay, let me simplify here so that I will save myself that space. Let's simplify here. This is equal to, I've said, move this man behind the lane. This man comes before the lane. What do you have there? Minus sine x. This one first. Write the lane sine x. I have this. This one here plus cos x times cos x. What do you have there? What do you have there? Cos, is it cos x squared or cos squared x? Cos x times x. What do you have? Cos squared x. If I say cos x squared, is it correct? Cos x times cos x is what? Cos squared x. If I say cos x squared, is it correct? If I say cos x all squared, is it correct? This man is equal to cos squared x. And this is also equal to, in brackets, cos x all squared. But it is not equal to cos x squared. Please take note. This one and this are the same thing, but it's not the same thing as this. So please take note. Why? Because in this case here, observe that square affects cos and x. In this case here, square affects only x, not minus the cos, which is wrong. So this will now give you what there? Cos squared x all over sine x, right? All right. So I have 1 over y into dy dx. It's equal to, what do I have there? Minus sine x ln sine x plus cos squared x all over Sin x. What do you do next? Move y, Abby, over here. Now, let me do something here to save me the stress of overwriting. Let me do something here. Listen. Well, yeah. It's still the same thing, but listen. Just listen. Listen. I want to do something here. And here's what I'm going to do. If you have, look at this, please. If you have y is equal to minus 2 plus x, for instance, right? Okay, fine. Minus x plus 2, for instance. Here's the catch. You do not start up an equation using a negative term. It is not wrong, but then it is not very proper. What am I saying? I'm saying that in a case like this becomes y equal to, you take the positive first before negative. So it becomes what there? 2. This is how to express it professionally. Why am I showing you this? Because looking at this stuff is started with what there? Negative. So what do you do there? Switch them. I'll take this first before this. If I leave this with it wrong, it's not wrong, but not very professional. That's just it. All right, so let me just switch them. So switching it becomes the cos squared x first. Cos squared x over sin x minus sin x ln sin x. All right, so I have this. Now it looks better now. What's my next step there? Take y over here. Abby? Yep. So I'll have that dy dx. It's equal to, move y over here, becomes what there? Y into everything there. So y multiplies everything here. Cos squared x all over sin x minus sin x ln sin x. What's the value of x? Bring back the value of y. But what's y? So I can say but y is equal to, what's y there? Sin x power what there? Cos x. So bring it back here. What do you have there? Dy dx is equal to y. What's y there? Sin x power what there? This is y multiplying everything here. Cos squared x over sin x minus sin x ln sin x. All right, basically that's your answer. This is now the answer for the second part. For my main answer, I'll now combine everything. It's crazy stuff. Here's what it is. Final answer, please. Therefore, look up now. Look up. Dy dx. So hang on. Please give me my first dy dx. What do you have there? Huh? Hold on. X to power this into sex squared x ln x plus 1 over x tan x. The first one here. This plus second answer there. Sin x to power what there? Cos x into cos squared x over cos x squared x over sin x minus sin x ln of what there? This becomes the answer to that question. all of this. So what you have here is the answer to that question. All right. All right. Let's proceed, please.